You have learned circle in year 10. I'm not sure last year if you really go through that like with details, but just talk about what like a circle looks like that. So what decide the circle is where's the center and how long is the radius. So two things will decide the circle, the center and the radius. So we get a general equation. That's the general equation. Okay, x minus h squared plus y minus k squared equals to the radius squared. So this formula, okay, this formula is very unusual. It's not looks the same as the one we learned before, but that's just the unique equation for a circle. It's not y to be the subject, it's just like x, y all put on one side and equals to radius squared. So if you think about that, so the center, this circle, okay, we can look at this circle here. This circle is with center 0, 0 and with a radius of 1. So I can just write the simplest equation for the circle as x squared plus y squared equals to 1 squared. Because x minus 0 is x, y minus 0 is y. So you square that and then that equals to the radius squared. Okay, let's just not talk about the semicircle yet. We have a look at the example here. So we have x plus 1 and y plus 4. Then the center will be minus 1 and minus 4. Okay, so is the value can make the bracket become 0. Can you think about that? Like for the square root and cube root, we all make the linear become 0. And for the hyperbola and truncus, we make the denominator equals to 0 to find the asymptotes. We just like the value 0. We're trying to make everything into 0 and see what we get. That will be the key feature. So we make x plus 1 equals to 0 and y plus 4 equals to 0. We get minus 1 minus 4. That will be my center. And the radius equals to 5. Because it's 25 squared, that will be 5. So to sketch that, there are a lot of key points we need to label in this question. So we have minus 1 minus 4. Okay, that's the center. We'll label our center first. And then you go each direction by unit of 5. So that one will be minus 1 and 1 because go up by 5 units. And you can go down by 5 units. That's minus 1 and minus 9. So the x will keep the same and the y value decreased. And you can go. Yeah, it's not on the graph. It's just the center. It's not on the graph. Center is not part of the graph. Your graph is the outside circle here. So that's just the center. You from that center go around. It's not one point on the circle. A good point. That's actually good thinking. So you understand what the equation means and what should be on the graph. And then you have point left or right. 4, negative 4, and minus 5, and minus 6, and minus 4. Minus 6 and minus 4. Okay, that's all these points. Okay, that's all these points. So we connect all these points. Okay, so you don't need to really draw it like as a perfect circle, but like something looks like circle, not ellipse, okay, not ellipse, not square. So just show like a circle. So don't just connect the 4 points and then say that's a circle. Well, I really see students doing this, okay? So like not that straight, but like something just a little bit curved. Well, at least don't draw straight lines. There's no straight lines. So, important thing is we still have xy intercepts. Okay, we still have xy intercepts. So when we have xy intercept, we need to work on that. So we work for x-intercept. So when x equals to 0, what I will have is 1 squared plus y plus 4 squared equals to 25. Y plus 4 squared equals to 24. Y plus 4 equals to plus minus root 24. Y equals to plus minus 2 root 6 minus 4. 4 times 6 is 24, so 2 root 6 minus 4. So that's the y intercept here. So 2 root 6 minus 4, and then that one is 0 minus 2 root 6 minus 4. And you can use the similar method to find the x-intercept as well. Just like, because we don't have enough time, I will give you this as homework to complete that one. Find the x-intercept, just write down for yourself, just find the x-intercept, and we can check answer on my Tuesday class. But let's have a think about the domain. What's the domain will be? Anyone can see the domain? Four. Yep. And range? What type of relation is that? A one-to-one, many-to-one, one-to-many, many-to-many, many-to-many. Circle is a many-to-many relation. It's not a function. Okay, it's a relation. It's not a function. There's no fx notation for that. That's just a relation. Okay, find x-intercept. I'll write it here, so you remember to do that. Find x-intercepts. There will be 2 x-intercepts. Okay, let's have a look at the second one. What kind of graph do you think this will be? Have a smart guess, a circle. Can you see the center? No, not yet. What do you need to do? Okay, so what can be a circle? We have x squared, y squared in one equation with the same sign and with the same coefficient. That will be a circle. Okay, so x, y have the same coefficient, 1. Then that will be a circle. So how you can make that into a circle will be completing square. Okay, complete square. So you complete x with x and y with y. Any constant not necessary, go to the other side. So we have x squared plus 6x. You will plus a 9 and subtract 9. And then the second lot is y squared minus 4y plus a 4 and minus a 4. And then you have a plus 2. So that's what you're adding. Well, you should be able to know how to complete square. So here we have x plus 3 squared minus 9 plus bracket y minus 2 squared minus 4 and then plus 2 equals to 0. So x plus 3 squared plus y minus 2 squared, that will equals to 11. Okay, my question is, what's the radius and what is the center? Yes, radius is root 11, not 11. Okay, that's just something. When it's in a square number like 25 or 9, it's very easy. You can pick it up. Okay, you need to square root that. But when it's a number, you can't square root it. So sometimes you may feel just take 11 as the radius, but it's not. It's actually square root 11. Okay, what's the center? -3 and 2. I'm not going to sketch this one, like you go to complete this by yourself to sketch, but I want to show you one thing. Well, because you said not teaching you how to use your calculator, so I'll just teach you, because I'm doing circle, tell you how to use calculator to sketch a circle. So you go to the graph page, go for menu. Because this is not y equals to something, right? It's not fx equals to something. There's mixed with x and y. It's all combined together. So what you do is you for graph entry edit. Number 3. Menu number 3. And then there's number 3 called equation template. See, there are all these things with a particular form, which is when y not the subject.
Do you ever use this? I could use this. I was spending so much time trying to write down my equation.
Okay, that's the circle. Shh. No discussion, please. If you have question, you ask. Okay, there are 2 forms for circle. One form is we have x minus h squared plus y minus k squared equals r squared. That's the standard form. Or you can have like the center form, or you have the standard form with the expanding form. You just use the expanding template. Okay, use the expanding template. So for this one, what we have is x squared, y squared. So, well, we have 1x squared, 1y squared, and 6 and minus 4. We can put a bracket, and then plus a 2. Okay, that's the circle. Yes?
Why does it automatically do it like when you type it, you put a 1 in front of the x squared? It automatically.
Maybe it's just my pen. No? Jane's clever. I don't know, like if you just move up, you can move back. I think maybe they say auto fill in those boxes. But my one not stop working when I do the second and the third one, so
Yeah.
not sure.
But can it be, do you have a 1 in front of the x squared and then a 3 in front of the y squared?
Yeah, but that's not the circle anymore. You must have the same coefficient for x and y, so it's not the circle anymore. Oh, you mean if you put a 1 and then it's automatic jump another 1 for you? Okay, that's because if it's not the same, then it's not the circle. So you will draw ellipse. If you learn spec, that would be the ellipse with different coefficients. Okay. What I will suggest you, like for the calculator, like you can just look at the menu. It's very straightforward. The good thing for this calculator is like you can see, like if you really type into the graph and then this one, you can see all of this name of your equations. You know what are they, and you just type in and you can sketch for them. So it's quite straightforward. For example, you have a linear. Sorry, that's not the right linear I'm talking about. This linear. Okay, you can draw a vertical line. Okay, so you can draw vertical lines. Normally, you don't have x equals something. You can just draw a vertical line here. And then you can use the standard form, like x plus b, y equals to c form to sketch for it. You don't need to make it y equals mx plus c. So it can be quicker if you use this template to sketch. Okay, just like once remember something, I will just go through some. Yeah?
Can you, in your CAD, if you have an equation in one form, can you type it into your CAD and then put it into the other form?
I can only make y to be the subject. Like I can't go for example, y goes to 2x plus 1 and put into x plus by form. That's hard to achieve. But I can, if you give me 2x plus 3y equals to 9, I can put y equals mx plus c form easily just by solving the equation solve for the y. So that's what we can do. Okay, now sketching number 2, skip number 2, and then I want to jump to the circle, semicircle. Shh. For the semicircle, okay, a lot of students, okay, I see a lot, they just confused with what is a square root and what's a semicircle. They don't know what are they. Okay, they see the function, they draw a square root for me. What I can do? Mark 0. Because you don't have all the key features. You need to have center, you need to have like those up and down and left and right points. But if you draw it as a square root, that will just be a 0 because you don't have any of these key features. So how do you distinguish between a square root function or a semicircle function? Semicircle got the quadratic inside. Okay, that's a quadratic inside. For square root function, that's a linear inside. We only have 2 functions with square root. One in semicircle and the other one will be the square root. Okay, when you see this, what you can do? First of all, you will see what is the subject. What is the subject? Okay, y is the subject. Okay, y is the subject. So if y is the subject, that will be the top or bottom semicircle. Okay, I only have 2 situations, at the top or bottom. If you go here, that's a square root with square there. And then x is the subject, then it's a left or right semicircle. Okay, that's how you distinguish that. When you see x to be subject, it's definitely only left hand side or the right hand side. Y to be the subject, it's only top or bottom. And then the next thing you look at is the sign in front of the square root. Okay, the sign in front of the square root. So you have a negative sign. That means a bottom. That means a bottom. If you have a plus here, that means the top. Okay, that means the top if you have a plus here. Similarly, we have negative in front of the square root. That means a left. If you have positive, that's a right. Okay, left is this half and right is this half. So you need to know the shape first. Okay, when I look at this equation, I already know what the shape will look like. Okay, what the shape will look like. Okay, in front of the square root. In front of the square root. So I can have a plus. I can have a plus. So that will be a right hand side semicircle. Okay, now next thing will be a little bit complex. Is I want to rearrange it back into the normal form. So what I will have here is y minus 2 equals to negative a root 9 minus x plus 1 squared. And then I want to square both sides. Okay, why I'm doing this? Because I want to see where's my center and where's the radius. What is the radius? So now I have y minus 2 squared equals to 9 minus x plus 1 squared. So x plus 1 squared plus y minus 2 squared equals to 3 squared. So now I can see my center. My center is negative 1 and 2. And also I can see my radius. My radius is 3. Okay, you must rearrange it right. Okay, you must rearrange it right. I have quick ways to look at it, but I don't think, I think this will confuse you. So better not to teach you that method. Just rearrange it into the normal standard form, like the center radius form, and then you can see the center and you can see the radius. And therefore plus, we know this is a bottom semicircle. I know that's the shape of my graph. So I will find my center at 1, negative 1, negative 1, 2, negative 1, 2. Negative 1, 2 is here. Because I only have the bottom one, so I have this point. I have this point. And I have this point. So the shape of my graph looks like this. That's negative 1 and 2. That's 2 and 2. That's negative 4 and 2. And that's negative 1 and negative 1. And also you can find xy intercepts. There's 2 x-intercept, but only have 1 y-intercept. Yeah. Yeah. Yeah, it's possible. No, they'll tell you, no, that's not going to be a problem. Like, it will tell you this is a circle, or like it's all really obvious. And with a center, you can see the center? Problem won't get the center there. If there's a center, it must be a circle. Yeah, also all the same distance from each side. Yeah. Yes. We don't need to connect it. It's not part of your graph. It's not part of graph. Your graph is only from here to here. Yeah. Yeah. What's the domain, everyone? And range? Negative 1 to 2. Only stop at the point 2. And it is to find all the xy intercept. I'm not going to do that now. You do it by yourself and we can check it. Well, I'll still write it here. When I upload the solution, you can see it. Okay, use the rest of the time to sketch a complete graph for that one. This I already tell you is the left-hand side semicircle. Find the center, find the key points, find xy intercept, talk about the domain and range. Okay, you have 10 minutes to do that. Yeah, question 6.